Yeah, let's try one more. I have time. I'm guessing. Day 15, timing is everything. The halls open into an interior plaza containing a large kinetic sculpture. The sculpture is in a sealed enclosure and seems to involve a set of identical spherical capsules that are carried to the top and allowed to bounce through a maze of spinning pieces. Oh, okay, yeah, a kinetic sculpture. I got it. I've seen those before. Part of the sculpture is even interactive. When a button is pressed, a capsule is dropped and tries to fall through slots in a set of rotating discs to finally go through a little hole at the bottom and come out of the sculpture. If any of the slots aren't aligned with the capsule as it passes, the capsule bounces off the disc and soars away. You feel compelled to get one of those capsules. The discs pause their motion each second and come in different sizes. They seem to each have a fixed number of positions at which they stop. You decide to call the position with slot 0. Oh, I see. You decide to call the position with the slot 0 and count up for each position it reaches next. Furthermore, the discs are spaced out so that after you push the button, 1 second elapses before the first disc is reached, and 1 second elapses as the capsule passes from one disc to the one below it. So if you push the button at time equals 100, then the capsule reaches the top disc at 101, second disc at 102, third disc at 103, and so on. The button will only drop a capsule at an integer time, no fractional seconds allowed. Okay, that makes it easier to program. For example, at T0, you see the following arrangement. Disc 1 has 5 positions at time 0. It is at position 4. Disc 2 has 2 positions at time 0. It is at position 1. If you press the button exactly at time 0, a capsule would start to fall. It would reach the first disc at time 1. Since the first disc was at position 4 at time 0, by time 1, it is ticked 1 position forward. As a 5-position disc, the next position is 0, and the capsule falls through the slot. Then at time 2, the capsule reaches the second disc. The second disc has a tick forward to 2 positions at this point. It started at position 1, then it continued to position 0, and finally ended up at position 1 again. Because there's only a slot position 0, the capsule bounces away. If, however, you wait until time 5, then when the capsule reaches each disc, the first disc will tick forward 5 plus 1 equals 6 to position 0. And the second disc will tick forward 5 plus 2 equals 7, also position 0. In this case, the capsule would fall through the discs and come out of the machine. However, your situation has more than 2 discs. You noted their position in your puzzle input. What's the first? How many discs are there? 6 discs. All right, let's put this into our input. Oh, I wonder if I have my get input working now. Get input 2016-15. Nope, I have to log in again. I guess there were some logouts. I thought I fixed this yesterday or the last stream after the stream was over, but I think I didn't. Yeah. Okay, so I'll just paste that in there. Not a problem. Git add input, git commit -m 2016 day 15 input. There. Okay, so let's set this up. .2016 day 15. Try to build it. Then we'll come over here and bacon. Oh, I want to switch my bacon back to release. No, that's okay. We can leave it as release mode for now. It does take longer to build though. Okay, so 2016 day 15, perfect. So let's use the test input as we do. Kill that. We have a disk 1. So what we should do is create a disk. Right, struct disk. And it has two items of information in it, right? It has the phase and the position count. I don't know. usize seems reasonable to me. So for each disk, it has a phase and position. And then we can implement for a given time. Well, let's implement a new function. Self phase positions. Right? Oh, that should build. And then for a given time, we want to know, is it 0? Is it at position 0, right? For any given time. And that should be easy enough to calculate. All we have to do is multiply the time plus the phase by, or mod it by the number of positions we have. Oh, we also need to know the disk number, because this is 1 second ahead, this is 2 seconds ahead. Okay, so let's do a num in there as well. Don't forget the comma. Put a num and a num. All right, so we have to say 0 at time. Mrs. Exeter, thank you for the follow. Welcome to the stream. Sup. And Vicarious. Oh, I got them out of order. Sorry about that. Vicarious, thanks for the follow as well. Much appreciated. Sorry, I looked at the top of the of my activity feed and I saw the wrong name. I wasn't expecting 2 at once. 0 at time. 0 at time, sure. For self, and we'll give it a time. Let's call it time. No reason to be silly. And that's going to return a bool, whether or not it's open at a given time t. So if we release at time 0, right, then we'll add 1 for disk 1 and we'll add 2 for disk 2. So it'll be time plus the disk number, right? And then we're going to also add the phase, right? What position it starts at. So this starts at position 4. So we'll add that in. Then we mod it by how many positions there are. And then we just say, is that 0? And if that's 0, then we know that time at time t, the disk will be at 0 by the time the little capsule gets to it. So given that, we do need to parse the input. That's going to be I think the hardest part of this thing. But what we can do just for now is we can just create a disk array or a disk vector, I guess. Oops, this is still messed up. Okay. Nope. Okay, this is still getting all wacky. Let's undo all of that, and just do this. Altisnips is nice sometimes and it's annoying some other times. Okay. So in this structure, we're just going to have a disk array, which is a vec of disk. And that way we can loop through all of the disks. And we need to be able to read them in, but for now we're just going to have test input. So we'll say self.push disk.new disk 1. I did phase then positions, right? So phase is 4 and positions is 5. And then we can say the same thing for disk 2. The phase is 1, and the positions are 2. Right? And now part 1 is just going to be finding a time where all the phases are 0. So we can just say for, loop, let mut time equals 0. For D in self disks, if D 0 at time, if not, then time plus equals 1, continue. Otherwise, break. This continue is, I meant to do this for this loop. So why don't we just do a found? While not found. There we go. And then this can just be a break. And this can be a found as true. Oh, this can be a break here, because we loop through all these guys. So this can be a loop. Okay, going back and forth here. And then, oh no, we don't want to break here. Yeah, okay, break again. That's why the while was better. Okay, never mind. This works though. And then this just is time. So let's see if we get time at is 5 using this test input. Or if we get an infinite loop. Missing disks. Vec. Yeah. Self disks push. Yeah. Oh, no. Oh, we got 1. Okay, so we have the wrong answer. That's nice. I'm going to switch this back to... I'm going to get rid of the release, because it takes too long to build. Yeah. Okay, so this didn't work. If not 0 time, then increment time and try again. And then we start over again with the disks. So we can just look at println. Let's make this debuggable so we can see which disk we're on. And we can say D : question mark. And then we could just compute whether or not it's the right phase. So D.0 at time. Println time. Okay. Oops. Argument is never used. False. So time should be equal to 1. Oh, continue again. There we go. Now it says 5. Okay. So that's the solution there. Let's get rid of these guys. And now we should be able to see it. Boom, 5. Okay, so now we want to be able to parse the input. So this is the test input. What is that going to do? I guess we can just do this. There. How do we parse? I've forgotten already. Input 2016, 15. So for L in AOC lib read lines input 2016, 15 dot text. We have the disk number here. we have the positions here, and we can ignore all of this business here. And so basically what we can do is split by space. L dot split on space. Collect vec I think it is. And that's just a vec of stirs. And then we have the disk number here, and we have the position here. So this is 1, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 3, and 11. So let's just print those out. 1, 3, and 11. Words 1, words 3, and words 11. That way we can see them. Yeah, look at that. Perfect. Okay, so we do have this little hash in front of it, the number sign, and then that should be easy to parse. And then these all have dots after them. I don't know if I can just, I wonder if I can ignore this part and just use the enumerate. I don't know if this is cheating. I don't know if other people have inputs that out of order. And then we have, so the disk number is going to be IDX plus 1. It doesn't like that. Oh, because it's, I have to say iter enumerate. There, yeah. So now it's 1, 2, 3, 4, 5, 6, and we have the disk number here. Words of 3 is easy enough to parse out, and then words 11 has a dot at the end. Oops. So what I can do is I can say self disks push disk new IDX plus 1 words of 3 dot parse usize unwrap, and then words of 11 dot split once on dot of unwrap dot 0 dot parse usize unwrap. And then after that, we can just say println self disks. And it panicked. Yay. So 170, 113.0, 170, 213.0, 332, 452, 517.0, and 619.7. Okay, so that worked. Unfortunately, we panicked at line 20, which is here. Oh, I have it backwards. I did phase, then positions. And so this is the other way around. Okay. Well, I came up with an answer. Let's get rid of the print, so it's not messy. Let's see if that's the right answer. It is. How about that? Okay, so we'll just Clippy think. Clippy's happy. Git status, git add source, git commit -m 2016 day 15 part 1. Now what are they going to do for part 2? After getting the first capsule, it contained a star. What a great fortune. Oh, good. Yeah, I have another star now, 29. The machine detects your success and begins to rearrange itself. When it's done, the disks are back in their original configuration as if it were time t equals 0 again. But a new disk with 11 positions and starting in position 0 has appeared exactly 1 second below the previous bottom disk. With this new disk and counting again, starting from t equals 0, what's the configuration of your puzzle input? Okay, So that means we have to refactor. I don't have it in my history, so I guess we'll just do that. We don't need this anymore. So now part 2 is insert another disk and do the same exact calculation. So we can just make a separate function like we did last time for day 14. We refactored. So let's refactor this. Let's call it solution for disks, and we'll just give it disks, which is disks, like that, and then it returns a usize. And then this does that, and then this just returns time. And then instead of self disks, we just do disks. Can we do it that way? I think so. And then all we need to do here is say solution for disks, self disks. Is that the same answer? 121834. It is. Okay. And now we just need to insert another disk. Let mut additional equals self disks clone additional dot push. There's nothing to parse. We just have to push this one disk on here. Self disks dot len +1, and then the phase 0. Right, it was phase then position. Phase then positions. Yeah, that feels backwards, but I'll live with it. And then for unsolved, we just say solution for disks additional, and that fails. We can't clone. Let's clone disks. We can't push because we select, oh, disks, new. Okay, well, it came up with an answer. It took longer, 236. 3 million. Wow, I have to wait 3 million seconds in days. Oh, I thought it could convert into hours. I thought Google will do that in hours. Or 2 hours? Oh, I have to say seconds to days. There we go. So I have to wait over a month, but eventually I get my capsule. All right. Yeah, I wasn't expecting it to be the wrong answer. Given the fact that we were able to solve it, I didn't even look, did I? I just assumed it was going to be right. Okay, that wasn't too bad. Git status, git, let's see, do a quick clippy here. Good. Git commit dash AM 2016 day 15 part 2. And that's going to wrap up my stream. Git status, git push. Here it is.